Hi guys, so this is the second part of the revision video for revision sheet 2, and we are looking at section B. It says show all work. If the limit as x approaches 0 of f of x and the limit as x approaches 0 of g of x exists, and the limit as x approaches 0 of f of x plus g of x equals 2, and the limit of f of x as x approaches 0 of f of x minus g of x equals 1. Find the limit as x approaches 0 of f of x multiplied by g of x. So to solve this one, we are going to use our limit laws. So firstly, we know that we can write the limit of the sum as the sum of the limits. So I'm going to write this as the limit as x approaches 0 of f of x plus the limit as x approaches 0 of g of x equals 2. And I'm just going to call that equation 1. And this I'm going to write as the limit as x approaches 0 of f of x minus the limit as x approaches 0 of g of x, which equals 1. That I'm going to call equation 2. So I'm going to say, I'm going to add equations 1 and 2 together. So then I have the limit as x approaches 0 of f of x plus the limit as x approaches 0 of f of x equals 3, because these two terms are going to cancel. Then I can write this as the limit as x approaches 0 of f of x plus f of x, because the sum of the limits equals the limit of the sum. This I can then write as the limit as x approaches 0 of 2 times f of x. And I can take the constant out in front of the limit. So it's 2 times the limit as x approaches 0 of f of x equals 3. And this means that the limit as x approaches 0 of f of x equals 3 over 2. I'm going to call that equation 3. So the important thing just to note is that you have to show all of the steps. So you have to show that you know what your limit laws are, and you have to use them correctly. What I'm going to do now is I'm going to substitute equation 3 into equation 1. So I'm going to get, let me just write that down, substitute 3 into 1. So then this was equation 1 over here. So I'm just going to replace the limit as x approaches 0 of f of x with 3 over 2. So I have 3 over 2 plus the limit as x approaches 0 of g of x equals 2. So that means that the limit as x approaches 0 of g of x will be a half. We were asked for the limit as x approaches 0 of the product. So this is going to be, so we have the limit as x approaches 0 of the product of f of x and g of x. And we know that we can write the limit of a product as the product of the limits. So it's the limit as x approaches 0 of f of x multiplied by the limit as x approaches 0 of g of x, which is then going to be 3 over 2 multiplied by a half, which is going to give us 3 over 4. For the next one, we have to find the equation of the tangent line to the curve. X cubed plus y cubed equals 1 plus 3xy squared. So what we're going to do here is, firstly, we are going to find the derivative by using implicit differentiation, and then we are going to find the derivative at the specified point. And once we have that, we can find the equation of the tangent line at that point. So let's start by using implicit differentiation. So I'm going to say it's 3x squared plus 3y squared dy dx equals, then the derivative of 1 is just 0, sorry, so we don't write that. So then we have a product here. So it's going to be the derivative of the first times the second plus the first times the derivative of the second. I'm going to take all of my terms containing dy dx to the left. So I have 3y squared dy dx minus, I'm going to write that as 6xy dy dx equals, and then I have 3y squared minus 3x squared. So I can take out dy dx as a common factor on the left. So then it's 3y squared minus 6xy. On the right, I still have 3y squared minus 3x squared. So dy dx is going to be 3y squared minus 3x squared over 3y squared minus 6xy. We want the tangent line at the point 2 minus 1. So I'm going to substitute those values into my derivative to find the gradient of the tangent line at that point. So that's going to be y is minus 1. So it's minus 1 squared. X is 2. So it is 2 squared there. 3 minus 1 squared minus 6 times 2 times minus 1. This is going to give us 2 minus 12 over 3 plus 12, which gives us minus 10 over 15, which is minus 2 over 3. Now, we have the gradient of the tangent line at that point. All we need to do is to find the equation of the line. So I'm going to substitute my gradient as well as my coordinates into this equation. So I have y minus minus 1 equals minus 2 over 3 x minus 2. So this is going to be y plus 1 equals minus 2 over 3 x plus 4 over 3. So y equals minus 2 over 3 x plus a third. And that's the equation of the tangent line at the point 2 minus 1. The final question says, consider the function f of x equals x over x minus 1. Write down the domain of f in interval notation. So there's only one x value that we cannot have in the domain, and that is the x value that will make our denominator equal to 0. So x cannot be equal to 1, and we have to write our answer in interval notation. So x is an element of the open interval from minus infinity to 1, or from 1 to infinity. Next, it asks us to determine the critical numbers of f and determine the intervals on which f is increasing or decreasing. So firstly, we're going to look at our critical numbers. So recap, what are critical numbers? Critical numbers is either where f of x does not exist, or it is where the derivative equals 0. So the first one is x equals 1. So this is where f of x does not exist. Secondly, we have to look at the derivative. So when is the derivative equal to 0? So let's first find our derivative. So it's going to be the bottom multiplied by the derivative of the top minus the top multiplied by the derivative of the bottom, all over the bottom squared. So this is going to be equal to 0 if our numerator is equal to 0. So our numerator is x minus 1 minus x, and the two x's will cancel, so we have minus x equals 0, but that's not possible. So we know that the derivative is never equal to 0, right? So the next part of the question is to determine the intervals on which f is increasing or decreasing. So what we do there is we look at our derivative. Now can you see that our derivative is going to be negative for all x in the domain? Why? Well, our denominator is always positive because any number squared is always positive. But our numerator is a constant value that's always negative. So we have a negative divided by a positive. So that's always going to be negative. So it's less than 0 for all x in the domain. And that means if our first derivative is negative, f is decreasing for all x in the domain. The final part of the question says, use the first derivative test and your answer in 2 to find the local maximum and minimum values of f if they exist. So, since the derivative is never equal to 0, we know that there are no local maxima or minima. So it does not exist since f's derivative of x is not equal to 0 for all x in the domain of f of x.